So we are on lessons 15 and 16, distinguishing volume and surface area. So 15.1, the science fair. May's science teacher told her that when there is more ice touching the water in a glass, the ice melts faster. She wants to test this statement, so she designs her science fair project to determine if crushed ice or ice cubes will melt faster in a drink. She begins with 2 cups of warm water. In 1 cup, she puts a cube of ice. In a second cup, she puts crushed ice with the same volume as the cube. What is your hypothesis? Will the ice cube or crushed ice melt faster, or will they melt at the same rate? So I put that the crushed ice will melt faster because there are more parts touching the warm water. The increased surface area will make the crushed ice melt faster. And so we're looking at this heart again. We calculated the volume of this heart-shaped box of chocolates. And so from yesterday, we know that the area of the box is 40. And so to find the perimeter of a triangle, you have to do, this is a square and this is b square. So you have to add these two, square these two, and add them together. And then square root it to get this. So that's where I got these lengths from, by doing this method right here. And so then I added all my sides together to get 25.6. And then I multiplied the perimeter by 2 because my depth of my box is 2 inches. And so I get this for the perimeter completely. And so to find my total surface area, I take my area twice and then plus this. So all these added together is 131.2 inches squared. And so we're skipping the chord sort. A wheelbarrow is being used to carry wet concrete. Here are its dimensions. And so this is a wheelbarrow, so just pretend like the top is open. What volume of concrete would it take to fill the tray? So we have to find the area of this first. And so I used these two to find the area of this rectangle. These two divided by 2 to find the area of this. And then I subtracted 40 from 106 to get what this length is. So 66 times 66 divided by 2 will give you this area. And then I added these 3 together to get this. And then my height is 70. So I multiplied my area times my height to get my volume. To find the perimeter of the base, it is 347, but you have to subtract the top. So 347 minus 106 minus 34 is 207. And the area of my long rectangle is 207 times the height, which is 70. And then I add those 3 together. So the area twice, because there's 2 of the bases, and then plus this area of the long rectangle, which is up here, to get 26,370 square centimeters. And so that is that lesson. Moving on to lesson 16. So for 16.1, for each situation, decide if it requires Noah to calculate surface area or volume. Explain your reasoning. So Noah is planning to paint the birdhouse he built. He is unsure he has enough paint. So he needs to measure or to calculate the surface area. So the surface area is what Noah will calculate because he would need to calculate how much area he needs to cover on the surface of the birdhouse. Okay. So Noah is planning to use a box with a trapezoid to base to hold modeling clay. He is unsure if the clay will all fit in the box. So he needs to calculate the volume. So the volume is what Noah needs we'll need to calculate because he needs to calculate how much space the box has inside of it to determine if it will hold all of its clay. So the volume is what Noah needs to calculate because he needs to calculate how much space the box has inside of it to determine if it will hold all of its clay. Moving on. So at a daycare, Kyron sees children climbing on this foam play structure. So I have to find this area of my base first. And so to do that, I kind of drew my little lines, making regular shapes. So I'm starting from left to right. So this little rectangle is 5 times 8, which is 40. So this wall of 5 plus this wall of 5 is 10. So 10 times 10 is 100. And then I split it like this. 36 minus 18 is 18. So 18 times 2 is 36. This 5 minus 2 gives this little length right here a 3. So 5 plus 3 is 8. So this length is 8. So 8 times 18 divided by 2 gives you 72. And then I add those 4 together, which gives me 248. And then to find the volume, because number 1 is asking for the volume, it's made out of the foam. I have to take my area of my base and multiply it by my height, which is 20, which is 4,960 cubic inches. And so for number 2, it's asking me to basically find my surface area, because it's asking for something that's being covered with vinyl. So my perimeter is 86, so I added all my numbers together. And then I multiplied my 86 by the 20. And then I took my 248 and multiplied it by this 2, or this 2. And so I added those two together, and I got 2,216 square inches for my surface area. So now, using all that information, the foam costs 80 cents per cubic inches. Here is a table that lists the cost for different amounts of vinyl. So what is the total cost for all the foam and vinyl needed to build this play structure? So I have to divide 0.8 by 100, which is 0.008. So I need to take my 4,960 and multiply it by 0.008, which gives me 39.68. And then I'm going to add these two together to get 1.2. Then I divide that by 2 to get 0.6. It's like finding my average of the cost. But then I'm going to divide it by 100, which gives me 0.006. So now my surface area is going to be multiplied by the 0.006 to get 13.296, which I'm rounding up to 13.30. And so then I'm going to add these two together to get my total cost. So 39.68 plus 13.30, which ends up giving me $52.98. When he examines the play structure more closely, Kyron realizes it is really two separate pieces that are next to each other. How does this affect the amount of foam in the play structure? I'm sorry, that's the. Are you ready for more? I'm not really going to complete that part. (16.3) Filling the sandbox. The daycare has two sandboxes that are both prisms with regular hexagons as their bases. The smaller sandbox has a base area of 1,146 square inches and is filled 10 inches deep with sand. It took 14 bags of sand to fill the small sandbox to this depth. What volume of sand comes in one bag? So I took my base area of my base and I multiplied it by my height and got 11,460, and then I divided that by 14 to get me about 819 cubic inches of sand. So number 2, the daycare manager wants to add 3 more inches to the depth of the sand in the small sand box. How many bags of sand will they need to buy? So 3 out of my 10 would be a fraction of 3/10, so it's 3/10 as many bags. So I multiplied 3/10 times 14, and I got 4.2. And so I need 0.2 of a bag, so I'm going to round it up to the next bag so that I can make sure I have enough sand. So that means I need 5 bags of sand. And then number 3, I'm really not going to read this, but I did the scale factor times itself. So I squared that to get 2.25. Then I took this number and I multiplied by 2.25 to get 9.45. Again, I need 0.45 of the sand, so I have to round it up to 10 bags of sand that are needed. And then so number 4, a lawn and garden store is selling 6 bags of sand for $19.50. How much will they spend to buy all the new sand for both sandboxes? So I'm dividing that, which I got $3.25. So for each bag is $3.25. And then so I added these two together to get 13.65, which I rounded up to about 14 bags, just like these two. So then I took my cost for each bag and I multiplied by the bags, and I will spend $45.50 on the sandbag boxes. And so now you need to complete the practice problems for lessons 15 and 16.